Today we're going to look at the divider-chooser method, where one person divides and the other person or people chooses. And so we're going to go through a couple of examples. And so one example here, we have two people, Martha and Nick. They bought a sandwich together. It's 77 inches long. It cost $36 and it has ham, turkey, and roast beef. In the picture below, you can see that it's subdivided. So from 0 to 22 inches is ham. From 22 to 55 inches, we can see we have turkey. And so let's just put in here that this is 23 inches long. And then from 55 to 77, we have roast beef. And so that's 22 inches long. So they bought the sandwich together and they're going to divide it into two. When they divide it into two, they're just going to make one cut and they're going to make one cut going perpendicularly along the sandwich. Okay, so when the person is dividing, we're going to assume they have no idea or of what the other person likes. We're also going to assume that they're going to try to divide this as fairly as possible. So they're going to split it into 50% of what they feel is worth of the sandwich and 50% what the other part is worth. And then the person that did not divide is going to choose. They give us a little bit of information about Martha and about Nick and their preferences. Again, but the other person doesn't know this. So they tell us that Martha likes ham sub twice as much than she likes the turkey sub. And she likes the turkey and the roast beef sub the same. Okay, so we have Martha. And it tells me that ham, she likes twice as much as turkey. And then she also tells me that she likes turkey and roast beef the same. So we want to choose a variable so that we can represent all of this. We could choose t because we can choose t is in terms of h and r. But I'm going to choose x is equal to the value Martha puts on one inch of turkey. Okay, so I know that if we look at summing this, so let's look at turkey. We have 23 inches of turkey. So if I look at the 23 inches of turkey, that's 23x. Plus, if I look at roast beef, she weighs roast beef just the same amount. So we could say 22 times x is how much she weighs each inch of roast beef. So now let's look at the ham. The ham is also 22 inches. But she likes this twice as much. So we're going to do 2x times 22. And then we're going to set this equal to the cost, because we're trying to figure out the cost per inch, which is total cost of the sandwich was $36. And so given this information, we can figure out how much 1 inch of the turkey sandwich Martha considers it cost. 1 inch of the roast beef and 1 inch of ham. So let's combine like terms on the one side and solve for x. So I see 23x plus 22x, that's 55x. Plus 2x times 22. Well, 2 times 22, so this is 44x, is equal to 36. So 55x plus 45x, this gives me 99x, is equal to 36. Get x by itself, we can divide both sides by 99. And so we get 36 over 99. I notice both of those have 9 in common, and so we can reduce this. 9 goes into 36 4 times, and 9 goes into 99 11 times. If you throw that into the calculator, you'll see that this is approximately 36 cents. Okay, so for the turkey, 1 inch of turkey is 4/11 of what she believes is the cost of 1 inch of the turkey. So let's see what else it tells us. So Nick likes roast beef twice as much as he likes ham, and he likes ham and turkey subs the same. Assume Nick and Martha just met and know nothing of each other's like or dislike. Assume also that the sandwich is cut along the width. Use the information for A and B. Describe how Martha would cut the sandwich into 2 shares, S sub 2 and S sub 1. Okay, so Martha's the one that's cutting it, that she's the divider. So let's just worry about Martha right now and how she would cut this. Well, let's first figure out how much she believes that the ham portion is. That's what she likes the most. Well, ham portion was equal to 2 times how much she likes the turkey. Let's just keep this in fractions for now, 4/11, because I rounded before and I wanted to be more accurate. So 8/11 is the worth that she feels for ham per inch. So 8/11 is equal to the amount one inch of ham is worth. Okay, so obviously my guess is she really likes ham, and so she's gonna want it to take more of the ham sandwich. And so let's figure out what is that cost of the ham sandwich for her portion. So our ham portion, well, it's 8/11 cost per inch times how many inches there are. Let me move this down. And so if we look at how many inches we have for the ham, that was 22 inches. So this is going to equal, well, I can reduce, 11 goes into 22 2 times, so this is $16. So the ham portion is worth $16 for her. And we know that her equal share of the sandwich well, the whole sandwich costs $36 divided by the 2 of them that are splitting it. So her total share cost is $18. And so that's showing me that she's missing $2 of her share to make that an equal share. Sorry, I want to move all this stuff down. So we need $2 into the turkey. So to make this a fair division, for Martha, she needs $2 worth of the turkey. So we need to figure out how many inches she needs to go into the turkey in order to get our fair share. I'm going to pause this while I move stuff around so that you don't have to watch me. Sorry about that. I wanted to move things around before I sat here for a minute and trying to do this. Anyway, so we're trying to figure out how many inches 2 inches of turkey is worth. Well, we knew that, let's just set up in a proportion. We know that 1 inch of turkey, that was equal to 4/11. Yes, this is dollars. We want to know how many inches of turkey. I'm just going to call this X right here. I know it's not the same X as up there. And that was equal to and this is equal to $2 worth. And so we have a fraction equal a fraction. We talked about this last class period. We can use the cross product to solve. And so we have 4/11 times X. So this is 4/11 X is equal to 2 times 1, which is 2. We can multiply both sides by 11/4. I'm just multiplying by the reciprocal so that that cancels, and I'm just left with X. So those cancel, and we're left with X here is equal to, well, 2 goes into 4, so this is 11/2, which is equal to 5.5 inches. So she needs to cut into 5.5 inches into the turkey. So there's 22 inches of ham, and there's 23 inches of turkey. Let me grab that picture. Oops. It's working with me. So we're going to grab it this way. Nope. Okay. So the 22 inches of the ham plus we're going to do 5.5 inches. So that's 27.5 inches. That's where she's going to cut it. So Martha is going to cut Martha is going to cut from 0 to 22 plus 5.5, so 27.5 inches. We're going to call this share 1. And then share 2, that would be the 27.5 inches to the rest of the sandwich, which is 77 inches. So for Martha being the divider, this is how she would split it. And she would be, they would both be worth $18 for her. Okay, so that was the first part of that question, and that's how she was going to split it. Part B says, is the cut shown in the figure, oops, that's a wrong problem. Oh wait. Again, let me pause so I can find the right piece of that problem. Okay, so I got the right piece back up. So part B says, after Martha cuts, Nick gets to choose. Specify which of the two shares Rick should choose and give the value of the share for Rick. Okay, so let's go back and read what Nick likes. So it says that Nick likes roast beef twice as much as he likes ham. So Nick, he likes roast beef. R is equal to twice of what he values ham. And then it says that he likes ham and turkey the same. So if we let Y equal the value Nick values an inch of, they're both in terms of ham. It's not racing. Nick values to an inch of ham. Well, right away, I can tell because he likes roast beef more. Obviously, he's gonna get this piece right here with the roast beef, right? He likes this twice as much. We just need to figure out how much he values this. So we can kind of set this up like we did before. And I kind of know that he values ham and turkey just because it has the same reasoning and dimensions as before. Ham and turkey he values as 4/11, and roast beef he values as the cost as, what was that, 8/11. So let's look at how much he gets. He doesn't get any ham, but he does get turkey. She goes out to 27.5 inches. So the portion of turkey, this is equal to, it stopped at the 55 inch minus, she started 27.5. That's telling me that he has 22.5 inches of turkey. And he has all of the roast beef, and that was 22 inches of roast beef. Add some more room. I just figured out how to do that. Maybe. So we have 22.5 inches times the cost of 4/11. Plus he has the 22 inches, which costs of 8/11. So this is the value of S2 for Nick. So if I do 22.5 times 4, this gives me 90. So this is 90/11. 22 times 8, which is 176/11. Got a common denominator, so this gives me 266/11. So the cost I'm getting is $24.18 is the worth of S2 for Nick. Okay, so let me pause here. I have some people coming into the house, so I don't want to get interrupted. Okay, so in that time of the pause of the video, I noticed that I did do something wrong. That 55 minus 27.5 should have been 27.5. So let's erase that if I can. So this really should have been 27.5. $27.5 times 4. This gives us 110. 110 plus 176, that's 286. And 286 divided by 11. Should get us, yeah, $26. So definitely Nick feels like he won. He got a lot more than half the worth of the sandwich when he got to choose the winnings or choose which part of the sandwich he wanted. Okay, so let's look at one more example. Now we're moving on to cake. Let me give some more room to myself. Okay, so we have two people here. We have David and Paula. They're planning to divide this cake. This cake is split into chocolate, vanilla, and strawberry as shown. Using the divider chooser method, David likes chocolate cake and vanilla cake the same, and he likes both of them twice as much as he likes strawberry. Paula likes vanilla cake and strawberry cake, but she's allergic to the chocolate cake. Suppose David is the divider and Paula is the chooser. We're going to complete the following examples. Oh, I didn't need that. Space. Okay, so let me get rid of that space. Add some space in here. That's what I wanted. Okay, so who is this chooser? It's shown before, David. Okay, so we need to see, is the cut that is made in the figure, the right, a 50-50 cut that David might have made as a divider? If so, describe the share Paula would give to the value as a percent of the following. Okay, so let's go back up here and let's look at what David thinks and what Paula thinks in terms of what they like. So it tells me that David likes chocolate and vanilla the same. So chocolate is equal to vanilla. C equals B. But he likes both of them twice as much as the strawberry cake. So chocolate he likes as 2S, and vanilla he likes as 2S. If we're looking at Paula, they give us a bit of information, and they say that Paula, well, she likes vanilla and strawberry the same, but she's allergic to chocolate. Okay, so here I can tell that vanilla is equal to 50% and strawberry is equal to 50% of the value of the cake for her, where chocolate is equal to 0%. If we look at David, though, he likes all of them, but just not necessarily the same. And so let's turn this in terms of all of strawberry. So chocolate and vanilla are the same. Chocolate is equal to 2s plus vanilla, which is equal to 2s. So I have 2s plus 2s plus strawberry. This is equal to 100%. And so if I sum that together, I'm getting that I get 5s equals 100. Okay, so 5s equals 100. So s is equal to 20%. So if he likes strawberry, 20% of that is the weight. He likes chocolate, then is equal to 2 times that, which is 40%. And he believes vanilla is equal to 40%. Okay, so now we're given that he split this up. Or did he? Did David split this up 50-50? So if we look at this, it looks like that he subdivided halfway down in between. Another thing that might be helpful to know is that we know a full circle is 360 degrees. If we divide 360 by, well, another thing we can know is that each piece is worth a third. And he split that strawberry in half. So there are ways we can do this. So if I'm looking at S sub 1, well, this is all of the chocolate. And so we know all of the chocolate for Dave is worth 40%. Plus he has this part, which is half of the strawberry, but he only values the strawberry as 20%, that whole piece of strawberry. And so this is equal to 40% plus 10%, 0.50, which is 50%. So if he views S sub 1 as 50%, then he has to view S sub 2 as 50%. So this was a fair, what did it say? Is the cut shown in the figure on the right a possible 50-50 that David might have made as a divider? So yes, this is 50-50 for David. Okay, so if so, describe the share Paula should choose and give the value in percent. Okay, so we know that Paula is deathly ill of chocolate and she's not going to choose the chocolate. So she's not going to choose the side that has S1. So Paula's going to choose share 2, S sub 2. Well, we know that the vanilla is worth 50%, so 0.50, plus the weight of the strawberry. Well, all of the strawberry was worth 50%, but she's only getting half of the strawberry. So this is equal to 50%, 0.50, plus 25%, 0.25, This is 75%. So she definitely gets more than half of the share, and she's a happy camper. Okay, so same kind of idea. Let's just look at a cake again. Same values, they believe, but this time they cut it a little differently. And so this time, looking at this, looking at the right at this picture, is it a possible 50-50 cut for David? Might have been the divider. If so, describe the share Paula should choose and give the value in percent. If the cut is not a 50-50, give the value of the 2 shares for David. Okay, so let's look at it. He thinks that, remember David, his values was chocolate was 40%, 0.40. He said that vanilla was worth 0.40 and strawberry is worth 0.2. And so for S of 2, well, this is half of the chocolate. So half of the 40% plus all of the vanilla. So 1 times 0.40. So this is worth 60%. So this is not a fair division or a 50-50 division for Nick. Not Nick, sorry, different player, David. So if that's worth 60%, well, 100% minus 60%, S of 1 is equal to 1 minus 0.60. So this would equal to 0.40 or 40% would be his share. Okay, so one more example, same likes and dislikes, same cake, but they subdivided it a little differently. So the cut now, it looks like they did all of the strawberry and half of the vanilla, but a portion of chocolate went to each. So really, they didn't cut it down the middle. And we want to know, is this fair division for Nick? Nope, David. Nick wants cake too, that's why. Okay, so let's look at S of 1. This is equal to, well, they have half of the vanilla, so half times 0.40. Plus, we have to figure out here what portion he has of the chocolate. So that's 30 degrees. I know that 120 degrees is equal to the portion of chocolate. So 30 divided by 120, this is going to give me 1/4. So this would be 1/4 of the weight of all of the chocolate, which for him was worth 40%. So this is equal to 0.20 plus 0.10. All right. And so this would be equal to 0.30. Let me just pause for a minute and just make sure that all my work is right. Okay, so I know I did something wrong. That 30% is not with the S of 1. So it's 30% minus 120 minus 30, so it should have been 90% here of the chocolate. 90 out of the 90 degrees out of 120, which is reduces to 3/4. So this should be 3/4 times. And so 3/4, 4 goes there, that's 0.30, which is 50%. Okay, so this was a 50-50 split for David. And so now we want to figure out how much they're going to, or which slice that Paula would choose. Well, again, she's not going to choose the slice that has chocolate because she's deathly allergic to chocolate. I don't know, deathly. Sounds better. Actually, if she was deathly, she probably wouldn't eat it, touching it. Anyways, 50-50 split. So how much is this worth? She's gonna get the piece probably with the least amount of chocolate. So we're gonna say that Paula is going to take S of 2. And then let's look at S of 2. So 1/4 of chocolate. Well, S of 2, 1/4 of chocolate for Paula. Well, that doesn't weigh anything for her. So that's plus times 0. Plus all of the strawberry. The strawberry was worth 50% for her, so 0.50. Plus half of the vanilla. And all the vanilla is worth 50% for her. And so we have 0.50 plus 0.25. And so she believes she's getting 75% of the value of the cake by choosing share 2. Okay, so these two examples, or last examples that we were looking at, only had 2 players, only 2 people dividing. So sometimes more than 2 players are dividing. And so if that's the case, one person has to be the divider. If the person is the divider, they're gonna have the other people get to choose first before they get any say of what they get. And so if that's the case, they're going to want to split things as equally as possible. So let's look at the following. Okay, so you have 4 partners. They're dividing out a plot of land using a 1 divider method. After the D divides the land into 4 shares, S of 1, S of 2, S of 3, and S of 4, the choosers, 1, 2, and 3, submit their bids for these shares. And so we're going to answer the questions A through D, or A through C. Okay, so let's just look at this. We have a divider. We have chooser 1. We got chooser 2. And we got chooser 3. They're dividing this up into 4 different pieces. S of 1, S of 2, S of 3, and S of 4. And so in here, they put what they believed. Suppose that the chooser's bids are the following. So in order for it to be a fair share, they only believes, chooser 1 only believes S of 3 is fair. If I go to chooser 2, they believe share 2 or share 4. And chooser 3 believes share the split 3 or split 4. And since the divider split, they believe they're all equal and he would be happy with any of them. And so suppose this, we want to find a fair division. Well, fair division here, C sub 1 has to get share 3. They don't believe anything else is fair. And so in order to get at least a quarter of the value, it'd have to be S sub 3. Okay, well that's okay. C sub 2 didn't choose S sub 3 as being one of the ones. And so they're either going to get S sub 2 or S sub 4. Well, we could give them S sub 2. Well, if we gave S sub 2 to C sub 2, well, then C sub 3 technically could get S sub 3 or S sub 4. If we give S sub 3 to them, then the divider would get S sub 4. Okay, so this was only one possibility. I notice that there's multiple possibilities that could work here. Right? So again, we know that C sub 1 has to get, oops, S sub 3. I did not do that right. We gave 2 people S sub 3. How dare me. Okay, S sub 3 cannot go to chooser 3. That would have to be, and that means divider. So chooser 3 would have to get S sub 4. If that was the case, that would mean that they would get S sub 1. So is it possible that we split this up a little differently? Okay, well, again, chooser 1 has to get S sub 3. Let's look at chooser 2. Chooser 2. Let's say in this case, we give them S sub 4. Well, then chooser 3, the only other one that they like is S sub 3. Oh, that doesn't work. So this possibility, there's only one possibility that this can work. Okay. Okay. So let's say instead the divider split up, and this is what the following believed on their bid on how things were weighted. Let me add some room. Okay, so this time we have chooser 1 does S sub 3. So again, I'm going to just chooser 1, chooser 2, chooser 3. We have S sub 1, S sub 2, S sub 3, S sub 4, and we have the divider. Just to keep it organized. Chooser 1 feels that S sub 3 is fair and S sub 1. And we find chooser 2, they believe S sub 2 and S sub 1. Chooser 3 is S sub 2, S sub 3. And so let's go through and figure if we can find the fair, oops, I didn't mean to do that, share. Okay, so let's give chooser 1 S sub 1. So if I give chooser 1 S sub 1, then I could give chooser 2, well, they can't have S sub 1, it's already gone. And so we can give them S sub 2. That's the only other one that they would like. Then chooser 3, well, S sub 2 is gone, and the only other one they like is S sub 3. So that would mean the divider then would get S sub 4. Okay, so let's say we did this a little differently. See if we can find a different case. So there's one possibility. Chooser 1, well, if they didn't get S sub 1, they would have gotten S sub 3. So if they got S sub 3, C sub 2, it doesn't really matter. Let's see though. Yeah, it does. C sub 3, S sub 3 was one of their choices. So the only other thing they could get is S sub 2. Well, if they got S sub 2, then C sub 2 would have to get S sub 1, which would leave the divider with S sub 4. So there's another possibility that could work. Okay, so let's say that chooser 1 only believes, though, there's only one fair lot or piece of land. So again, let's make our chart. So we have chooser 1, chooser 2, chooser 3, and the divider. Lot 1, S sub 1, lot 2, S sub 2, lot 3, S sub 3, lot 4, S sub 4. Okay, so C sub 1 only likes S sub 4. So we know that C sub 1 has to get S sub 4. So C sub 2. C sub 2 likes S sub 3 and S sub 1. And C sub 3 likes S sub 3 and S sub 2. Divider likes them all equally. And so, well, we had to give S sub 4 away. Because of this person, no one else is ever going to get S sub 4. C sub 2, well, they could take S sub 1 or S sub 3. So we can give them S sub 1. If we give them S sub 1, well, C sub 3, S sub 1 doesn't affect them at all. They could get S sub 2 or S sub 3. Let's just give them S sub 2. And that would give me, the divider would give me, they would have to take S sub 3. So there's one division, that's fair. C sub 1 again has to take S sub 4. If I had given C sub 2 S sub 3 instead, that means the only thing available for C sub 3 would be S sub 2. And that would give the divider S sub 1. And so those are the two possible cases that would be fair division, or everybody would be happy. They would get at least a quarter of their the share, which would be good for them. Okay, so another example. This time we have Diane, Brady, Alan, Cody, and they're sharing a cake valued at $20 using the lone divider method. The divider divides the cake into 4 slices, S sub 1, S sub 2, S sub 3, and S sub 4. The table to the right shows the value of the slices in the eyes of each player. Complete parts A through D. So who is the divider? So if you're looking for who is the divider, you're looking for the person where they subdivided this equally. Well, if the cake is worth $20 and there's 4 people, $20 divided by 4, that's $5. So is there anyone in there that subdivided everything as $5? And there is. So Alan is the one that has each 4 slices worth $5. So find a fair division of the cake. Choose the correct answer. Okay, so we have to figure out which ones believe which shares are fair. So again, it's $5 or more is worth a fair share. For a player. So Diane, she doesn't think S of 1 is. S of 2 works, S of 3 will not, S of 4. Brad, they don't like S of 3 or S of 4. I'm just crossing out all the ones that won't work. Cody doesn't like S of 2, S of 3, or S of 4. So looks like Cody only likes one thing. So Cody has to get S of 1. That takes this away from everybody else. And so looking at this, well, that then makes Diane has to get, because S of 1 is gone, she has, the only other one she likes is S of 3. So no one else can have S of 3. And so the only thing that Brady has left that they like is S of 4. And then the divider, Alan, gets the leftovers. Well, he divided and he believes they're all the same. So S of 2. Okay, so now you got 5 players are dividing a cake amongst themselves using the lone divider method. After the divider D cuts into 5 slices, S of 1, S of 2, S of 3, S of 4, S of 5, and choosers, chooser 1, 2, 3, and 4, submit their bids. These are their shares, or submit their bids for their shares, complete A through B. So A, suppose the chooser's given the following. Chooser 1 gets S of 3 and S of 5, or chooses, those are what they believe are fair shares. Chooser 2 chooses S of 3, S of 5. Chooser 3, S of 1, S of 3, S of 5. Chooser 4, S of 2, S of 3, S of 5. So in the fair division, where C sub 1 receives S of 3. Okay. So I think it's, to me, it's kind of helpful to write my chart. So I'm going to do it anyways, even at what I know that chooser 1 gets. So again, we have 4 choosers, then we have the divider. Chooser 1, chooser 2, chooser 3, chooser 4. Really, the divider, they're going to get the leftovers. And S of 5. So chooser 1, S of 3 tells us above. No. So chooser 1 chooses S of 3 and S of 5. Chooser 2, oops, sorry, that was chooser. Also chooses S of 3, S of 5. Chooser 3 does S of 1, S of 3, S of 5. Chooser 4 was S of 2, S of 3, S of 5. So in this fair division, if we give C sub 1 S of 3, what would we give everybody else? Okay, so that means no other chooser can get S of 3, so I'm just going to cross it out. And so that would mean that chooser 2, the only other option for chooser 2 would be S of 5. Chooser 3, so if that's the case, I'm going to cross that out. Chooser 3 only has S of 1 left. Oops. And then chooser 4 we get S sub 2. So the divider gets what's left. We have S1, 2. They need S sub 4. Okay, so same kind of example, but this time their bids are as follows. So let's do it. C sub 1, C sub 2, C sub 3, C sub 4. And the divider. S sub 1, S sub 2, S sub 3, S sub 4, S sub 5. Okay, so C sub 1, S sub 4 is the only one they believe would give them a fair share or above. C sub 2 chooses C sub 4 or C sub 5. C sub 3 chooses S sub 1, S sub 4, S sub 5. C sub 4, chooser 4 chooses S sub 3, S sub 4, S sub 5. The divider, they're happy with amongst anything. Okay, so C sub 1 has to get S sub 4 because that's the only thing amongst the division they find is fair or above. So if that's the case, then that means C sub 2 has to get S sub 5. So that would give C sub 3, the only thing left for them is S sub 1. And good thing, because C sub 4, the only thing left for them would be S sub 3. And the divider then would get S sub 2. Okay, so one more example. We got 4 partners, Egan, Fine, Gong, and Hart. Jointly own a piece of land and the market value is $480,000. The partnership is breaking up and the partners decide to divide the land among themselves using the lone divider method. Using the map, the divider divides the property into 4 parcels, S sub 1, S sub 2, S sub 3, and S sub 4. The accompanying table shows the value of the parcels and the eyes of each player. Complete parts A through C. So who was the divider? Okay, well, first of all, they didn't give us all the information, and we could probably, we can figure out, like, we need to figure out what the amount is for everybody. So we know that the total amount of property is $480,000. So let's figure out what S sub 3 is for Egan. So we have the $175,000 plus the $100,000 plus the $95,000. That's $370,000. And if we take that from $480,000, this tells me this is $110,000. So same kind of idea I want to do with Fine. So we got $120,000 plus the $125,000 plus the $100,000. So what he listed is worth $345,000. So $480,000 minus that answer. That gives me $135,000. So parcel 2 is worth $135,000 for them. So Gong, $120,000 plus $195,000 plus $80,000. This is equal to $395,000, taking that away from $480,000. That gives me $85,000. There's 4 partners, the land, the assets. divided by the number of splits equals our fair share amount. So if I look at 480,000 divided amongst the 4 people, this is 120,000. So Hart believes each piece that they split up is worth 120,000. Okay, so we know that Hart is the divider. Determine each chooser's bid. List all partials, 4 parcels for each divider. Okay, so we have Egan, we have Fine, Gong, and Hart. We got S of 1, S of 2, S of 3, and S of 4. Egan, anything that's 120,000 or above, he believes is fair share. So Egan believes S of 1 is fair share because that's above 120,000. S of 2, no. S of 3, no. S of 4, no. Fine, 120,000 and above, so that would be S of 1, S of 2, S of 3. Gong, anything 120,000 and above would be S of 1, S of 2, and that's it. And then Hart, he's the divider. They're all worth 120,000. So determine the each bid, so we did that. Find the fair division of the property. Well, it looks like Egan, he has to have S of 1. So fine, we're going to get rid of S of 1. I'm just going to put a line through it so we don't give it back to anybody. And so fine can either have S of 2 or S of 3. If we get rid of 1, S of 2 though, then Gong won't like anything. And so we're going to have to give fine S of 3. And so that means that Gong would get S of 2, which means Hart gets what's left, which is S of 4. So we come up with a fair division of all the property amongst all 4 players. Okay, so hopefully this helps. These are problems from my math lab and homework or similar to homework that you have due next week. And I will see you in class on Tuesday at the normal time.